It is the last week of June. The heat has already arrived. Temperatures in much of the country are hitting the upper 80s and crossing into the 90s almost every afternoon. And the 7-day forecast on my phone says it is only going to get hotter from here. You just did an alcohol wash on your strongest hive yesterday, and the mite count came back at 3.5 mites per 100 bees, well above the treatment threshold, and climbing fast in the warm weather that is accelerating mite reproduction in every colony you own. You reach for your Formic Pro strips and you read the label again to confirm what you already know. Maximum ambient temperature for application, 85 degrees Fahrenheit. Above that, the formic acid can damage your queen, kill open brood, and cause significant adult bee mortality. The instructions are clear. Do not apply above 85. And your forecast for the next 2 weeks shows no day cooler than 90. So what do? You have a colony with a rapidly growing mite population that needs treatment within days, not weeks. Your formic acid is unsafe at the temperatures that are coming. Your oxalic acid vaporization can be done, but it does not reach mites inside capped brood. And your colony is at peak brood production right now in late June. You are caught between a mite population that is about to explode through July and a treatment toolkit that does not match the heat that just arrived. This exact problem is one of the most common sources of distress messages I receive from viewers in the southern United States, Texas, the Gulf Coast, and increasingly the entire country, as summer heat starts earlier and runs longer every year. And the answer to it, an answer that European beekeepers have been using for over 30 years and that North American beekeepers are slowly starting to discover, is a compound called Thymol. With June just ending and the hottest weeks of the year ahead of us, this is the exact moment to understand this tool. Today, I am going to give you the complete, honest picture of Thymol as a Varroa treatment option. What it is, how it works, why mites cannot develop resistance to it, how to use it in standard Langstroth and in horizontal hive systems, and most importantly, when it makes sense to choose Thymol over the other organic acid options available to you before July hits and you are out of time to plan. Welcome back. I am May Holloway, and I want to be clear about something before we get into the details. Thymol is not a miracle cure for Varroa. There is no miracle cure for Varroa. Anyone who tells you they have found one is either selling something or does not understand the biology of the problem. What Thymol is another well-documented, scientifically validated organic compound that fills a specific gap in the Varroa management toolkit. Specifically, the gap that opens when temperatures exceed the safe operating range for formic acid and you still need to address mites in capped brood that oxalic acid alone cannot reach efficiently. Thymol fills that gap better than any other approved treatment in North America. Everything I share in this video is based on published research from European and North American apicultural institutions, where Thymol has been studied extensively over the past 3 decades. All sources are linked in the description. The European Union has approved Thymol-based Varroa products for organic certified beekeeping operations since the 1990s. In the United States, Apiguard, the most common Thymol product, received EPA registration in 2002. This is not a new or experimental compound. This is an established, proven tool that simply has not received the same attention in North American beekeeping communities as the more common synthetic options and the more recently approved oxalic acid treatments. Today, I am filling that information gap. What is Thymol? Thymol is a naturally occurring monoterpene compound, that is the technical chemical classification, found primarily in the essential oils of thyme and oregano plants. The thyme plant species Thymus vulgaris that grows wild across the Mediterranean basin and in herb gardens throughout the world contains thymol as one of its dominant chemical components. Researchers have known since the 19th century that thyme essential oil has antibacterial and antiparasitic properties. What modern apicultural research demonstrated beginning in the late 1980s and through the 1990s is that thymol specifically, purified and standardized, has powerful effects against the Varroa destructor mite at concentrations that honeybees tolerate well. According to research from Dr. Antonio Nanetti at the Italian National Research Institute for Beekeeping, thymol applied in controlled concentrations inside a beehive achieves mite mortality rates of 75 to 90% over a treatment period, depending on temperature and application method. That efficacy range is comparable to or exceeds most synthetic miticide options, while leaving no toxic residues in wax or honey. The compound is volatile at hive temperatures, meaning it sublimates from solid or gel form into vapor that distributes throughout the hive air. Worker bees and mites both come into contact with the vapor during normal hive activity. The mites absorb thymol through their cuticle and through respiration. The bees tolerate the exposure because their physiology is different enough from mite physiology that the dose lethal to mites is well below the dose harmful to bees. This selective toxicity is the foundation of all approved Varroa treatments. The compound must kill the parasite without killing the host. Thymol achieves this margin reliably across the temperature range where it is approved for use. 3 mechanisms of action. Now, the part that makes thymol genuinely unique among Varroa treatments. Most miticides, both synthetic and organic, work through a single biological pathway, a compound that disrupts one specific neurological or metabolic process in the mite. The advantage of single pathway treatments is targeted efficacy. The disadvantage is that single pathway treatments create selection pressure for mites that have any biological variation in that specific pathway. Over generations of treatment, the resistant variants reproduce more successfully than susceptible ones, and the population shifts toward resistance. This is the biological mechanism behind the well-documented resistance that Varroa populations have developed to multiple synthetic miticides, including fluvalinate and amitraz, over the past 3 decades. Thymol works differently. According to research from Dr. Peter Rosenkrantz at the University of Hohenheim, thymol affects Varroa mites through 3 distinct biological mechanisms simultaneously. Mechanism 1. Neurological disruption. Thymol interferes with neurotransmitter function in the mite's nervous system, particularly at the GABA receptor sites that regulate inhibitory signals throughout the nervous system. The result is uncoordinated movement, inability to grip the host bee, and eventual paralysis. Mechanism 2. Respiratory disruption. Thymol vapor enters the mite's respiratory system through the spiracles and disrupts oxygen exchange at the cellular level. Mites exposed to lethal concentrations of thymol vapor cannot maintain adequate cellular respiration and die from oxygen deprivation. Mechanism 3. Sensory disruption. Thymol interferes with the mite's chemoreceptor function, the chemical sensing system that allows mites to detect host bees, locate brood cells for reproduction, and communicate with other mites. A mite that cannot sense its environment cannot find hosts to feed on, cannot enter cells to directed feed reproduce, and cannot survive even if the direct toxic effects of thymol do not kill it. The combination of 3 independent mechanisms attacking simultaneously creates a profound problem for resistance development. For a mite population to develop resistance to thymol, it would need to simultaneously evolve variations in neurological function, respiratory physiology, and chemoreceptor biology. The probability of all 3 changes occurring together in a single mite is vanishingly small. Research from the European Reference Laboratory for Honeybee Health has documented 30 years of European thymol use with no observed development of resistance in field mite populations. 3 decades of use, no resistance. This is the unique advantage of thymol among Varroa treatments, and the reason it deserves a serious place in your management toolkit. Thymol versus formic acid. The most useful way to understand when to use thymol is to compare it directly to formic acid, because the two compounds occupy overlapping but distinct positions in the organic acid treatment landscape. Both are organic compounds. Both are approved for use in certified organic honey production. Both kill mites at efficacies above 70% under correct application conditions. The differences are significant, and they determine which compound is right for your specific conditions. Temperature range. This is the most consequential difference. Formic acid in its commercial formulations, Formic Pro and Mite Away Quick Strips, has an upper temperature limit of approximately 85 degrees Fahrenheit. Above this temperature, the formic acid releases too rapidly from the polymer carrier strips. The concentrated vapor can kill open brood, damage or kill queens, and cause significant adult bee mortality. Below approximately 50 degrees Fahrenheit, the release rate becomes too slow for effective mite kill. Formic acid works in a temperature window of roughly 50 to 85 degrees Fahrenheit. Thymol products, including Apiguard, have an approved temperature range of approximately 60 to 95 degrees Fahrenheit, depending on the specific product formulation. The upper temperature limit is 10 degrees higher than formic acid. In the southern United States and during summer heat waves across most of the country, this 10-degree difference is the difference between a treatment you can use and a treatment you cannot. Brood penetration. Both formic acid and thymol have the critical capability that oxalic acid lacks. The vapor penetrates capped brood cells and kills mites inside them. This is why both compounds are valuable during periods of full brood production, when oxalic acid alone leaves a large proportion of the mite population untouched. Research from the University of Guelph documented brood penetration efficacy of both compounds and found them comparable at appropriate application doses. Queen safety. Formic acid at temperatures near its upper limit can damage or kill queens. This is a documented and consistent finding across multiple research studies and is the primary reason for the temperature restrictions on formic acid products. Thymol at approved doses has not shown significant queen mortality in field studies. Research from the Apicultural Institute at the University of Graz tracked queen status in over 200 colonies treated with thymol products across multiple seasons and found no statistically significant queen damage attributable to the treatment. This queen safety profile is one of thymol's most valuable practical advantages for beekeepers who cannot afford to lose queens during summer treatment. Treatment duration. Formic acid treatments are short, typically 7 to 14 days depending on product. Thymol treatments are longer. Apiguard treatments run for 6 to 10 weeks total across 2 applications spaced 2 weeks apart. The extended treatment period of thymol means you need to plan it carefully in your season, but it also means the treatment is gentler in its daily intensity. Brood and adult bees experience lower concentration exposure over a longer period, rather than high concentration exposure over a short period. For sensitive colonies or colonies under other stress, the gentler thymol profile is often advantageous. Commercial thymol products. If you decide thymol fits your situation, here are the products you should know about and how they differ from each other. Apiguard. This is the most widely available thymol product in the United States and Canada. Manufactured by VitaBee Health in the United Kingdom, Apiguard comes in gel form, packaged in individual 50-gram trays. You open one tray, place it directly on the top bars of the brood box, close the hive, and the gel releases thymol vapor over approximately 2 weeks. After 2 weeks, you place a second tray. Total treatment period is typically 6 weeks from start to finish. According to the manufacturer's specifications and validated by independent research from the University of Florida, Apiguard achieves mite reduction of 70 to 90% under recommended application conditions. A 2-pack of Apiguard typically costs between $15 and $25 at beekeeping suppliers in the United States. ApiLife VAR. This product, manufactured by Chemicals LAIF in Italy, uses Thymol combined with 3 other essential oil components: eucalyptus oil, menthol, and camphor for synergistic effect. The product comes as small ceramic tablets that you break in half and place at the corners of the brood box. Treatment cycle is shorter than Apiguard, typically 3 applications at 7 to 10-day intervals over 3 weeks total. Research from the Italian Beekeeping Association documented ApiLife VAR efficacy comparable to Apiguard, but with the advantage of the shorter treatment cycle for beekeepers who need to complete mite treatment before specific seasonal deadlines. Thymovar. This product, manufactured by Andermatt Biovet in Switzerland, is more common in European beekeeping than North American, but is available through some specialty suppliers. Thymovar uses thymol soaked into cellulose strips that you place on top bars of the brood box. The strips release thymol gradually over 3 to 4 weeks per strip, with typically 2 strip rotations per full treatment. Cost is similar to Apiguard. Mite Away strips, note this is not the same as Mite Away quick strips, which are formic acid. Mite Away strips specifically are a thymol product manufactured by NOD Apiary Products in Canada. They use a similar polymer strip delivery system, but with thymol as the active compound. Less widely available than Apiguard in the United States, but well distributed in Canada. All 4 products work on the same active compound, thymol, and achieve comparable efficacy under their respective application protocols. The choice between them is largely based on availability in your region, your preferred application format, and your treatment timeline. For first-time thymol users, I recommend Apiguard because it has the broadest United States distribution, straightforward application protocol, and the most accessible technical support if you encounter questions during use. Application in horizontal hives. This is the part of thymol application that does not appear in most beekeeping resources because horizontal hives are still a minority hive type in North America, despite their growing popularity. The standard application instructions for Apiguard and similar products assume a vertical Langstroth configuration, where you place the treatment on top of the brood box with empty superspace above. The thymol vapor distributes upward through the colony as a natural convection current. In a Long Langstroth or Layens hive, the geometry is fundamentally different. There is no vertical stacking. The colony exists in a single horizontal chamber, and the vapor distribution mechanics are different. Here is how I apply thymol in my Long Lang colonies. Step 1. Position the treatment tray or strips near the center of the colony cluster rather than at the edge. Vapor distributes from the application point outward through the hive. In a horizontal hive, the center position ensures vapor reaches both ends of the colony space efficiently. In a vertical hive, the bottom of the top bar's position accomplishes the same goal because vapor rises naturally from that location through the cluster. Step 2. Apply directly on top of the brood frame top bars, not on the bottom board. Thymol vapor moves both up and laterally, but the top bar position takes advantage of the warm air rising from the cluster, which carries vapor through the colony space. Step 3. Adjust the follower board position to compact the colony space if needed. A colony with excessive empty space on either side of the cluster wastes thymol vapor, distributing it through unoccupied hive volume. Tighten the follower boards to approximately 1 frame width past the active cluster on each side. This concentrates the vapor exposure where the bees and mites actually are. Step 4. Ensure the top of the hive is sealed, but with sufficient ventilation for safe air exchange. Excessive ventilation dilutes thymol vapor too quickly. Inadequate ventilation can cause vapor concentration to spike above safe levels. The standard inner cover ventilation hole in a typical Long Lang design provides appropriate balance. Step 5. Temperature monitoring is even more important in horizontal hives than vertical ones. The greater thermal mass of typical horizontal hive construction means internal hive temperatures lag behind ambient temperature changes. Check internal hive temperature during treatment if you have a thermometer installed. Actual internal temperature matters more than weather forecast temperature. Research published in the Italian Journal of Apiculture documented that thymol application in horizontal hive systems achieves comparable mite reduction efficacy to vertical applications when these positioning and ventilation adjustments are made. For Long Lang and Layens beekeepers who have been wondering whether thymol treatments are practical in their hive system, the answer is yes, with these specific modifications to standard application protocols. Myths and mistakes. There are several persistent misconceptions about thymol that I want to address directly because they prevent beekeepers from using a valuable tool. Myth 1. Thymol contaminates honey and gives it a medicinal taste. This concern comes from the strong smell of thymol products during application and the intuition that anything that smells that strongly must be flavoring the honey. The research does not support this concern at properly timed applications. According to research from the Federal Research Center for Nutrition and Food in Germany, honey harvested from colonies treated with thymol during the recommended late summer treatment window after honey supers are removed, shows no detectable residue and no measurable taste impact in trained sensory panel evaluations. The key qualifier is timing. Thymol applied during active honey flow with supers on the hive can leave residues in the honey. Never apply thymol with honey. Supers in place. This is the same rule that applies to all Varroa treatments and is the foundation of safe organic acid management. Myth 2. Thymol does not work in hot weather. This myth confuses thymol with formic acid. In fact, the opposite is true. Thymol's effective temperature range extends to 95 degrees Fahrenheit, which is significantly higher than formic acid's upper limit. Thymol vapor pressure increases with temperature, meaning warmer conditions actually accelerate vapor distribution through the hive. The practical upper limit on thymol is determined by bee tolerance to the vapor concentration, not by treatment efficacy. At temperatures above 95 degrees, the vapor concentration can reach levels uncomfortable for the colony, causing them to beard excessively or, in extreme cases, abandon brood. Within the approved temperature range, thymol performs better in warm weather than cool weather. Myth 3. You need to wear special protective equipment to apply thymol. Thymol is far less hazardous to humans than formic acid or oxalic acid vapor. Standard beekeeping protective equipment, gloves, and a veil is adequate for thymol application. You do not need respiratory protection beyond a basic dust mask if you are sensitive to the strong smell. This makes thymol significantly more accessible to beekeepers who find oxalic acid vaporization intimidating due to the respiratory equipment requirements. Now, 3 common mistakes I see beekeepers make with thymol treatments. Mistake 1. Applying during honey flow with supers on. Already covered above, but worth repeating because it ruins honey crops and creates the persistent contamination myth. Mistake 2. Treating when temperatures are too cold. Below 60 degrees Fahrenheit, thymol vapor pressure is too low for effective distribution. Late fall treatments after temperatures have dropped are not effective. Mistake 3. Discontinuing the second application after. The first treatment seems successful. The 2 application protocol exists because mites inside capped brood at the time of first application emerge over the following 2 weeks and need the second application to kill them. Skipping the second application leaves a significant proportion of the mite population untreated. 3 years ago, I ran a direct comparison between thymol and my standard oxalic acid vaporization protocol across 6 hives in my apiary to test whether thymol deserved a permanent place in my management. Here is what I did and what I found. I divided 6 similar hives into 2 groups of 3. All 6 hives showed comparable mite loads in late July, with alcohol wash counts ranging from 2.1 to 2.7 mites per 100 bees. Group A received Thymol treatment using Apiguard starting August 1st. 2 tray applications spaced 2 weeks apart for a 6-week total treatment period. Group B received my standard extended-release oxalic acid vaporization protocol, 4 vaporization treatments at 7-day intervals, same start date. I did follow up alcohol wash counts on all 6 hives at 6 weeks after treatment start at the end of September and again in late October. Results at 6 weeks. Group A Thymol, average mite count of 0.3 mites per 100 bees, range 0.1 to 0.5. Group B oxalic acid, average mite count of 0.7 mites per 100 bees, range 0.3 to 1.1. The Thymol treatment achieved slightly better mite reduction in this comparison, but both treatments were within the expected efficacy range. Results at end of September. Group A Thymol. Average count had crept up slightly to 0.5, reflecting new mite reproduction in the colonies after treatment ended. Group B oxalic acid, average count 1.2, showing faster mite population rebound after the discrete treatment period ended. Results at late October. Both groups received my standard fall oxalic acid dribble treatment after the colonies became broodless. Both groups went into winter with negligible mite loads. Both groups survived winter at typical rates for my apiary. The practical conclusion I drew from this experiment: Thymol works. It achieves comparable to slightly better mid-season efficacy compared to my standard oxalic acid protocol. It has the advantage of extended treatment duration, which provides longer suppression of mite population recovery after treatment. And critically for me, it works at temperatures above the formic acid threshold without queen damage risk. Since that experiment, I have incorporated Thymol into my regular rotation. I now use it as my primary treatment in late July through August when temperatures are highest, and my standard extended-release oxalic acid vaporization in May through June and September through October when temperatures are more moderate. This rotation gives me 4 advantages: temperature-appropriate treatment in every season, different active compounds rotated to maximize mite mortality at each treatment window, reduced reliance on any single treatment which protects against any unexpected resistance development, and peace of mind during the hottest weeks of summer when formic acid would be unsafe. Thymol is not a replacement for the other organic acid options in your toolkit. It is a complement to them that fills a specific gap in temperature range and brood penetration that no other tool fills as well. Use it in summer when temperatures exceed the formic acid range. Use it when you need brood penetration that oxalic acid alone cannot provide. Use it when you want extended-release treatment that maintains mite suppression over weeks rather than delivering it in a single intense pulse. And avoid it during active honey flow with supers in place, because that is the only scenario where Thymol creates problems rather than solving them. All sources for today are in the description. Dr. Antonio Nanetti at the Italian National Research Institute for Beekeeping on Thymol efficacy. Dr. Peter Rosenkrantz at the University of Hohenheim on Thymol mechanisms of action. European Reference Laboratory for Honeybee Health on resistance monitoring. University of Guelph on brood penetration. Comparison. Apicultural Institute at University of Graz on queen safety with Thymol. University of Florida on Apiguard field efficacy. Italian Beekeeping Association on ApiLife VAR application. Federal Research Center for Nutrition and Food Germany on honey residue testing. And Italian Journal of Apiculture on horizontal hive applications. Tell me in the comments whether you have used Thymol in your apiary and what your experience has been. If you are in Europe and have been using these products for years, your perspective is genuinely valuable to North American beekeepers who are just beginning to discover them.